Hello, hello. So, as part of Redis replication, the slave nodes register themselves with the master nodes, which happens through a three-step handshake process. And I'll try to implement the entire slave side of the handshake in this video. And in the next video, we'll implement the master side of the handshake. So, the handshake has three parts, as I said. And in this stage, we'll implement part one of the handshake that happens when a replica connects to a master. When a replica connects to a master, it needs to go through a handshake process before receiving updates from the master. These are three parts of this handshake. The replica sends a ping to the master. It then sends a REPLCONF and then PSYNC. We'll learn more about REPLCONF and PSYNC in the later stages, in the next two stages. For now, we'll focus on the first part of the handshake, sending a ping to the master. The tester will execute our program like so. They'll run our instance as a replica of a master. It'll then assert that the replica connects to the master and sends the ping. So as soon as my slave node starts, it needs to send a ping to the master node. But okay, so I have some sort of a diagram created for it. So if this is a slave node and this is a master node, the initial connection takes place. The Redis replica sends a ping to the master responds with a pong. And then it sends a REPLCONF command, followed by the port that the slave is listening on. And the master returns an OK. Then the slave sends a REPLCONF and it sends its capabilities, as in how much of the data or see there are different capabilities. We'll learn more about that in the later stages, but this is an example of a command that would be sent from the slave node to the master node. The master node would process it and then return with an OK. And after that, the slave node will send a psync command, which we learn about in the next stage or next stage. And the master will process that and return a full resync if the slave node needs to resync the data from the master completely from scratch. Okay, so that in this stage we'll implement the support for the ping. So when my slave node starts, it needs to send a ping to the master, right? But this handshake needs to happen in a separate thread. As soon as my slave node starts, it's ready to serve client's data as well. But it needs to sync the data from master. So this handshake and the process that's handling the clients, these two are supposed to happen on different threads. So I know that because I've suffered through that. I did that in a single thread and it didn't work. So I'm just letting you know that's how we're going to implement it going forward. And okay, so let's get right to it. Okay, so in a previous stage, in a previous video, I said I'll figure out how to make CodeCrafters skip my tests. And what I had done was I had written this here, but that doesn't work. Why it doesn't work? Because we need to give it before this deader param, and this should work actually. Okay, so that's it for this. So now CodeCrafters will skip the tests that we have written right here. Okay, so let's think about it. When I start my instance, we're going to have, why is it throwing an error? It's just IntelliJ cache issues. Let me restart IntelliJ by clearing its cache. Give me a moment, please. IntelliJ is restarting, and now it's working fine. IntelliJ is wonky like that sometimes, and I've seen that a lot. So just restart, just invalidate your cache from here, and that should work. Okay, so where were we? So yeah, let's think about it. So when we start a slave node, it's different from a master node, right? So why are we calling the same method for both? Doesn't seem right. If my slave server behaves very differently from the master server, we should refactor our code such that the single responsibility principle, right? So the slave server class should be different from the master server class. At least that's what I think, and that's what I'm going to do. I'll refactor this into TCP server. I'll call it master TCP server because whatever we have implemented right now, it's all master logic. We have to now implement slave logic. So I'll do that in a separate class. Now the slave logic will be very similar to the master logic, so I'm just copy pasting right here and calling it slave TCP server. Now in my main class, I have a master app. Let's call that master, and similarly, I can get a slave component, a slave bean, like so, and instead of starting the server for app, I can check if we are currently a slave. Now that is stored in my Redis config dot get role. If it equals slave, we can start slave server like so. Else we can start the master server. And it should be passed the port. It doesn't actually need the port because the port is stored in a Redis config, right? So let me refactor that in the both places. Start server, it doesn't require a port because the port can be get from the Redis config. I cannot wire it. Like so. I can copy this and paste it in the slave class as well. Like so. So now in my main class, I don't need to pass it the port. Okay, is there anything else we need to do in the master class? I don't think so. In the main class, I don't think so. Yeah, seems about right. Okay, master's TCP server I don't need to touch. I don't need to change for this stage because we are only working as a slave and we have to implement the functionality of a slave. And for that, all the work will be in the slave TCP server class. Okay, so right here, we got the port and I'm connecting to that port and setting the IP address to be reused after after my application goes down. Okay, now I need to start. Uh, Now I need to do the handshake process, and that needs to happen on a separate thread. So I'll use completable futures for that. Completable future dot run a sync, and I'll create a method, and I'll pass a method reference. Shit. Ini. I'll call it initiate slavery method. Okay, I'll call the initiate slavery method here, and let's just create a method. All right. After my uh, slave connection, if my handshake is completed, I can then run some logic right here. Right, right now I'll just print if my connection is completed successfully. Yeah, like so. And yeah, that's it. Okay, so now I need to write the logic for this initiate slavery method. Right here, what we're supposed to do, I'm supposed to connect to the master node and send it some commands like ping, REPLCONF, and PSYNC. So the connection to the master will be a socket connection, and I'll do that in a try with block. It needs an IP address and a port, and we have that stored already in the Redis config. Get master host and get master port. All right. Here I can get the input stream out of the connection and the output stream. Like so. Now the format we'll write to the format in that will be written to the output stream is a byte array. We can't write simple strings because the master expects a byte array. As you can assume, everything is being done in bytes so far as well. Okay, so right here we need to send a ping, right? And that looks like so. I can just paste it right here. All right, got it. And we need to just write it to the master. Output stream dot write data, and then we can read what the master responded with as well. Let's do the bytes read equal to input stream dot read. I need an array to read into. Let's call that byte input buffer, and let's read into it. Input buffer. We'll read 1024 bytes, and it will return how many bytes were actually there in the output stream, and that will be returned to the array. We can convert it into string and then log it. String response equals to new string. And I'll just print the response. Okay, let me see if there's anything else that we need to do. Oh yeah, see, this is a slave instance, right? And a slave is not allowed, and you're not allowed to write to a slave. So we cannot be calling this command handler.set for a slave. Instead, a Redis slave instance returns this string. Yeah, we can simply return it right here because we are not allowed to write to a slave. All right. Handle command seems fine. Handle client seems fine. Initiate slavery seems fine. And the rest of it, all other works seem fine. Let's try and pushing. What's the name of the stage? I want to mention something here. Right now, we're not supposed to see. They are only testing that the replica connects to the master and sends the ping command, but they're not testing if the master returns right now. That will be done in this part. That's not being tested here. Here, all they are going to test is that our slave node is sending a ping command to the master. That's it. And let's push and check if our work's fine. Git push. So it's still running the tests. It shouldn't have. Anyways, the tests are passing. That's great. We can move forward with the next stages as well. Alright, we mark the stage as complete. So in the second part of the handshake, we need to send REPLCONF to the master twice. So these are the strings that will be sent to the master. All right, so let's get working on that. So we already have this set up for ping. Let's give some comments. Part one of so we need to send this to the master, right? Let's see what it actually is. It is bulk string serialized. Let's go slow and read. In this stage, we'll implement part 2 of the handshake. This part, after receiving a ping, the replica then sends two REPLCONF commands to the master. The REPLCONF command is used to configure replication. Replicas will send this command to the master twice. The first time it will be sent like so: REPLCONF, listening port, and the port of our slave node. This is the replica notifying the master of the port it's listening on. The second time it will be sent like so: REPLCONF, kappa PSYNC 2. This is the replica notifying the master of the capabilities. Kappa is short for capabilities. You can safely hardcode these values for now. We won't need to use them in this challenge. Okay. So it just needs to be sent. Ceremonial thing to do. We'll send it. These commands should be resp arrays. So these will look like so. For both commands, the master will respond with okay. Alright. We just need to send the string. So the REPLCONF string looks like this. Let me take you through that. It's just the same instead, but I have broken it into chunks of length of listening port and listening port, and I can calculate length of listening port like so. Redis config dot get port. I need to convert it to a string, then get its length. And the listening port, it's just Redis config dot get port. Okay, so that's the string that needs to be sent to the master. Let's call it part 2. It should then return an OK, and that I'll be logging right here. And after that, we need to send the second thing, the kappa piecing thing, to the master. That can be done like so. And instead of it being this, the data that we need to send is the psync command. Sorry, REPLCONF with kappa and psync. So that looks like this. I basically just copied it from here as it is, and I'm sending it to the master. Okay, let's test the code again. Okay, so pushed. Okay, so the test passed. We can move on to the next one. It will pass. Is the third part of the handshake. In this stage, we'll implement part 3 of the handshake that happens when a replica connects to a master. As a recap, there are 3 parts of the handshake. We're implementing this one right here. After receiving a response to the second, the replica sends a PSYNC command to the master. If you want to read what the PSYNC command is, you can go through the documentation. The PSYNC command is called by Redis replicas for initiating a replication stream from the master. And the REPLCONF command right here. The REPLCONF command is an internal command used by Redis master to configure a connected replica. Okay. The psync command is used to synchronize the state of the replica with the master. The replica will send this command to the master with 2 arguments. The first argument is a replication ID of the master. Since it's the first time the replica is connecting to the master, the replication ID will be a question mark because we don't know the replication ID. The second argument is the offset of the master. Since it's the first time the replica is connecting, the offset will be -1. So essentially, we just need to hardcode this string and send it to the master. So the final command will be, this should be sent as a REST array. The master will respond with a simple string that looks like full resync REPL ID, and this. It will return its REPL ID, and that we need to store in my Redis config. You can ignore the response for now. We'll get to handling it in later stages. We just need to hardcode and send this as well. Alright, let's do it. So instead, let's call it part 3 of the handshake. And instead of REPLCONF, I'll call it string psync. And what we need to send here is this. And I think we're good. Let's just print what. So eventually, in the next stage, instead of reading it from the input stream, we need to handle the input. Alright. That will be done right here. I'll add some comments for it. Yeah. Input stream. In the next stage, we'll need to implement this method right here, and we'll need to comment these lines. That will be done in this method, and we'll need to process whatever the master returns, the full resync, its REPL ID, and the data that we need, that we are reading from the master. The first, what's it called? The first initial replication stream. So whatever the data the master sends down to the slave, we need to store that in our store as well. So all that needs to be done in this method right here, and this needs to be removed. But for now we're good. We can log whatever the master is returning, and we'll be able to see this full resync REPL ID 0/r/n as well in the logs. So let's see that. It sent a ping. We got a pong. Receive bytes. See, after that, we receive this. So the logger is not logging right here. Why not? So what I'll do, instead of logging, let's try printing. And let's commit and push to the master again. Because I want to show you how, in what format we are receiving the response from the master. Okay, yeah, right here. Got it. And you see replication completed as well. All right. See, that was right here. Yeah, from here. When the handshake was completed, it printed out replication completed. And we received this in response from the master. A full resync with the replication ID of the master and the offset from where the slave needs to start reading from. And with that, our test, yeah, stage has passed, and we can move on to the next one. So the next two stages are the master side of this handshake, and we'll do that in the next video. That's it for this. That's it for this one, and I'll see you in the next.